Hi all, welcome to the course on operating systems. So let us see the different scheduling algorithms used in operating systems today. So before starting about the scheduling algorithms, we have to understand the very important parameter called process. What do you mean by process? The computer program that is executed by one or more threads are called as process. Now the question arises, what is thread? So flow of execution is nothing but your thread, because the role of thread is something which it keeps on tracking the instructions which are executed. So that is the role of threads. So collectively, if you have one or more threads, then it is called as process, because in each and every scheduling algorithm the process plays a very important role. Coming to the different scheduling algorithms, the first one is first come first serve, which is called as FCFS scheduling, or FIFO, first in first serve. So the role of this scheduling algorithm is the process that comes first, that has to be executed first. And talking about the second one, shortest job first scheduling. So from the word you can easily understand that the shortest time, the process which has the shortest time will execute first. So that is the role of shortest job first scheduling. The next scheduling is priority scheduling. So this scheduling is based on the priority of the process. So before the execution, we have to assign the priority. Based on the priority level, the process will execute. And the last one is round robin scheduling, which is called as RR. So it is a very simple concept, but it is a very popular concept which is used in many operating systems. Rotating round based on the quantum time, which is nothing but round robin scheduling. So now let us discuss each and every scheduling algorithms one by one. The first one is first come first serve scheduling algorithm. Okay, coming to the example of first come first serve. So in the video you can see we have three different process. One is P1, P2 and P3. So for each and every process there is a burst time which is 44, 6 and 6. So before understanding this scheduling algorithm, we should understand what is burst time first. Burst time is nothing but the time taken by the CPU to execute the process is nothing but the burst time. And let us take the condition 1. If the process arrives in the order P1, P2 and P3. So the order which is given here may change at any time. This order may be from P2, P1, P3 or P3, P1, P2. So any logic can be applied here and for the calculation. So let us consider that this order arrives in the order of P1, P2, P3. So now let us do the Gantt chart. Gantt chart is nothing but it is kind of a bar chart which is used for all the analytics. So let us take the chart for calculating the waiting time of process and average waiting time of the process. So let us do the table. So we have three processes, so P1, P2 and P3. So P1 has a burst time of 44. So indicate that 44 here. So initially it starts with 0 and now we have this 44 for P1, so we indicate the 44 here. Now let us consider P2 which has 6. So now you have to add 6 to this particular 44. So what happens? The value will become 50 now. Now again the P3 is allocated with 6 now. So adding 6 to this particular 50 will have a waiting time of 56. So these timing, the burst time which is allocated are nothing but the waiting time of the process. So let us consider the waiting time for each and every process and we will calculate the average waiting time. So waiting time for P1 is 0 because you can see that the P1 has to wait. It is the initial, this is the first process, so it has a waiting time of 0. The P2 has the waiting time of 44 and P3 has the waiting time of 50. So that's why it is given 0, 44 and 50. So average waiting time will be adding P1, P2, P3 divided by 3. So 0 plus 44 plus 50 will give you some value which will be divided by 3. So that will be the average waiting time, which is nothing but your 33.